A buffer solution is the one that resists a change in its pH even when you add some small amount of an acid or a base to it. Sometimes it is necessary that when you prepare a solution and we may have to store it for some time, and during this preservation of a solution, the solution may come in contact with the air, and that air contains carbon dioxide, and some of the reactions may take place which make it acidic. Okay, the carbon dioxide, that it is acidic, and if the solution comes in contact with the carbon dioxide, it may change in this pH. Its pH may change. It may become more acidic. Or there are some certain solutions where you see some side reactions are going on during that period of storing, and that may ultimately change the pH of this particular solution. Now if you want to store a solution at a definite pH, so we add some buffer solution in this mixture, in this solution. And what is a buffer solution? Buffer solution is a solution that resists a change in this pH when some small amount of an acid or a base is added to it. So when this carbon dioxide comes in contact with the solution, its pH will not change. Why? Because we have added some buffer solution in it. And what is a buffer solution? Buffer solution is generally a mixture of a weak acid and its salt, or a weak base and it is salt. So we can take an example of a weak acid, acetic acid, CH3COH, and its salt with a strong base like sodium acetate, CH3CONA. This is our weak acid and its salt. This mixture can act as a buffer solution. Similarly, we can have a weak base and its salt. This mixture can also act as a buffer solution, like ammonium hydroxide and its salt, like ammonium chloride. Okay, this mixture of a weak base and its salt will act as a buffer solution. Now this is an acidic buffer, this is an acidic buffer, and this is a basic buffer. We can prepare the buffer solutions of a specific pH by taking the appropriate amounts of an acid and a salt, or a base and its salt. So we can prepare the buffer solutions of the different pHs. Now let us see how a buffer solution resists the change in its pH. An acidic buffer of a weak acid and its salt, weak acid and its salt. In the mixture you have these number of the ions, acetate ion and the sodium ion and the H3O positive ion. Now this is our buffer solution, and what happens if you add acid? If you add some small amount of an acid in it, what's going to happen? How this will resist the change in the pH? In this mixture, when you add some when you add some H positive ions, when you add some acidic substance, this H positive ion, this added H positive ion will actually react with the acetate ion and it will form the CH3COH. So here the acetate ions will react with the added proton, the acid that we have added here, and it will form the acetic acid. So therefore it will neutralize the number of H positive ions that have been added to the mixture. So it will resist the change in the pH when you add some acid. Now what happens if you add some small amount of a base? For example, if you will add here some small amount of sodium hydroxide. So if you add a base, the hydroxide ion here, the hydroxide ion is going to react with the H3O positive ion over here. So this H3O positive ion over here will react with the base that we have added here. The mixture contains the H3O positive ions. The added base will react with the H positive ions and form the water here. So you can balance it now. This is 2 times. This is the hydroxide ion that has been added, and this is the H3O positive from the equation 1 from the weak acid. So again forms the water. So that means if you add acid or a base to this acidic buffer, to this mixture of a weak acid and salt, there will be no change in the pH because it will be consumed. Any H positive ion added will react with the acetate ions here, and any hydroxide ion added will react with the H3O positive ions here. So this will neutralize it. Similarly, we can write down this in the similar pattern, the buffer action of a basic buffer. Correct? So what about the basic buffer? Like we have ammonium hydroxide, the basic buffer, ammonium hydroxide. We can take an example of a ammonium hydroxide, and this dissociates into NH4 positive and the hydroxide ions, and we have ammonium chloride here, NH4Cl. This is the salt and formed with ammonium ion and the chloride ions here. Now to this mixture, to this basic buffer, if you will add some protons, right? If you add some protons here, some acid, the acid will give the H positive ions. This H positive ion is going to react with the hydroxide ion from the basic buffer, from this mixture. So the hydroxide ion is going to react with the acid that we have added and form the water. So it will neutralize the effect of the added acid. And in the same way, if you add now the sodium hydroxide, the base, hydroxide ion that we have added now to the mixture will react with the ammonium ion. Okay, this hydroxide ion is what we have added here from the base. It comes from the base, and this ammonium ion from the mixture, from the buffer solution, is going to react with the hydroxide and form with the ammonium hydroxide ion. So again it will neutralize its effect. It will again neutralize the effect of the base. So that means whether you add acid or a base to a acidic buffer or the basic buffer, it will resist the change in this pH.